This is page 4. We're going to finish up the 8th grade course material for benchmark 3. Question number 27 says you randomly survey middle school students and high school students about whether they prefer summer or winter. The results are shown in the tables. Create a two-way table that includes the marginal frequencies. So we have middle school students, and so there were 65 who liked summer and 68 who liked winter. And then the high school students that were surveyed, 34 liked summer and 74 liked winter. So the way that we do a two-way table is you do it in this manner. You have to take the information that they have, since they were asked the same questions. We're going to have those two categories. So let's do it in this. No, not like that. Let's do it in this way. So we'll break it down into this. And we'll say summer, winter. So those are the two categories. And then we're going to break it into technically 3 groups, because you want. So this is going to be middle school. This is going to be high school. And then this is going to be total. Okay, and then you actually have a total on the bottom also, both ways, hence the two-way. So you have total for both categories. So summer middle school is going to be 65. Summer middle school 65, and winter was 68. If we add those together, we get 133. High school was 34 liked summer and 74 liked winter, and adding those gives you 108. And then we total this way also, so we can see how many of both like the summer, and that's going to give you 99. And 68 plus 74 is 142. And if we add both of those should end up equaling the same number, 241. So we get to see how many middle school students, how many high school total students, and then we get to see how many like winter, how many liked summer, how many liked winter. And so the majority of them liked winter. Okay, that would be a two-way table. All right, number 28. Do the ordered pairs 111, 617, 810, 1910, and 199 represent a function? So a function is a very interesting thing, that when we functions have inputs and outputs. And inputs are traditionally x, outputs are y's. And then we also have inputs, or x's, are independent variables. Independent, and y, or outputs, are dependent. And that makes sense, right? It depends what you input. That is dependent. And then we also have x, or the input is called the domain, and the output is called the range. And these are all very important terms for functions. And functions are important, that every input should only have one unique output. Meaning if we have this equation, y equals 2x, when we input, let's say 3, if we input 3, we're going to get 6. And it's always going to be 6. Every time we input 3, we should expect to only get 6. If we inputted 3 and then got 5 the next time, that would not be a function, because that doesn't make any sense. How do you input the same number but get 2 different outcomes? So that's what functions. Functions just say, hey, for every input, there is one unique output. So in this situation, we see that we inputted 19 and got 10, and then we inputted 19 again and we got 9. That's bizarre. So this is not a function. So these ordered pairs do not represent a function. That's a quick little overview of functions. So graph the function, so we know that every input's going to produce a unique output. So we can do it in 2 ways. We can do it in this manner, where if we plug in 0, we get -3. If we plug in 1, we get 2. If you plug in 2, you get 7. If you plug in -1, you get -8. If you plug in -2, you get -13. So now we're going to graph that. We'll grab a graph from here, and we'll plot these points. So 0, -3, 1, 2, 2, 7, and then we can do -1, -8, and we notice that you get a nice straight line, a linear line. And of course, this is a linear equation, and so this would represent all the solutions. And maybe you've heard, and so we know every input has only produced one unique output, but we have this thing called the vertical line test. And some of you remember that. So a vertical line, you take it, and this represents all the inputs, right? This represents a input. And so this input here is -6, -5. So when we input 0, you see that we get this output, input and output. That's what a coordinate has, an input and an output. And we notice that there's always going to be just one point for every input. So that's called the vertical line test. So an example so this is a function, which we knew. So this is a function. If something wasn't a function, if we had a graph like this, and you had something, a graph like this, and we grabbed that vertical line, so one input, now we have 2 inputs, 2, 2. So this would not be a function, not a function, because we notice that we have 2. We input, let's say that this is 0. Let's make this -1. We notice that we have 2 values, 2 outputs for one input. So that point would be something like, we could make dashes. So this point would be -1, 1, and this point would be -1, -1. So notice the same input, but 2 different outputs. So this is an example of not a function. But in this case, it was, because we didn't have multiple points for one input. Number 30. 2 arcades charge an entrance fee and a fee per game. At Arcade A, the total cost, Y, in dollars of playing X games is represented by the linear function Y equals 0.5x plus 5. This is my entrance fee, and this is per game. So it costs $5 to get in, and every game is 5 cents. For this one, it costs $7, because when you play 0 games, you have an entrance fee. And then here's the tough part. Now let's see what the increment is. So that is +4. Now that's the x value. So when we do slope, you have y's over x's. So this increment is going to be that increment from the x is going to be 4, and the increment for the y is going to be 3/4. So the slope, and you'll notice that this is +3, this is +3, and this is +3. This is +4, +4, +4. They don't have to necessarily be the same, but this ratio from your difference in y's over your difference in x's, 3/4, 3/4, 3/4, must be the same. So this is 0.75 for each game. All right. So the question says, which arcade has the higher fee per game? That would be arcade B. So question A is arcade B has the higher fee per game. Higher fee per game. Notice that I gave a little bit more detail in my answer, and that took 10 seconds. So, look, take 10 extra seconds to be more specific in your answer. If you provide me less answer, then you're making it harder. And then which one has the higher entrance fee? Well, remember the higher entrance fee was $7. It was $7 for B. So arcade B also has a higher entrance fee. Arcade B has higher entrance fee. So I'm definitely not playing arcade B. I'm going to go to arcade A to go play my games. Number 31, determine whether each equation represents a nonlinear function. So when we look at functions, or when we look at things that are linear compared to things that are nonlinear, linear make a line, and they have to be in sort of one of these sorry, that's not the correct equation. One of these forms. It can be different, but they all end up being something similar to this. And linear equations have a constant slope. So that's the important thing, is each one of them has a slope. So does this have a constant slope? If I plug in the points, we notice that this had a constant slope, 3/4, 3/4, 3/4. So something that is linear, and it tends to be x to the first. X and y are in the numerators, and x is to the first and y is to the first. So if we distribute this, we get this equation. It's in slope-intercept form, and it has a constant slope. If we plugged in points, x's and y's, 0 is -4, 1 is going to be 8. No, sorry, and 1 is going to be 0. Sorry. Did the math too fast. 0. 2 is going to be 4. And 3 is going to be 8. So we notice that +1, +1. Let's do 5. Let's do 5. If we plug in 5, we get 16. So that's +2. So I just want to show that slope will still work. So this is +4. This is +4, and then if we go from here, this is +8. So if we do the slope 4 over 1, 4 over 1, 8 over 2, which still simplifies to 4. So that's a constant slope. So yes, this is linear. This is a linear equation. This problem, notice how I had mentioned about the variable x, it's in the denominator. And so nonlinear equations are going to be things like x squared, which gives you a parabola. It'll look like, whoops, it'll look, whoa. Let's delete that. It's going to look, oh, sheesh, what did I do? Big fat fingers on the pen. Nonlinear, x squared, x cubed is going to look like this. X to the 4th is going to look like this. X to the 5th is going to look like this. And you notice that all the even ones have a u, and it has symmetry to it. All the odd ones will be able to go into the negative quadrant, because a negative 3 times or 5 times or an odd time will produce a negative. We know that a negative with an even number of negatives will not produce a negative, it will always end up being positive, so that output will always be positive. So those are really your traditional nonlinear. Then you can have absolute values, and that shape looks like this. It looks like a V. You can have the square root of things, and square roots look like this. It's only one way. Actually, it's super faster. It's much, much faster going up. And then we have it in the denominator. The denominator is going to look like this. That's crazy. So that looks like that. So as you get bigger, your x, your bigger denominator, the smaller your output. And the smaller your input, the bigger your output. So that's a very unique. So this is non-linear. This is the shape of this one, which is cool. And then notice it doesn't touch 0. If you enter in 0, you're not going to get an output because 2 over 0 is no solution. So that's an important one for everybody to understand in 8th grade. And this, here we have an x squared, so this is going to shift, and that's just going to be a parabola. So this is also non-linear. Also, again, a parabola, which is non-linear. I don't think we have to sketch it. We just have to determine. All right, number 32. Create a graph for each situation. A, the temperature increases slowly at first and then more quickly. So let's do a temperature. So we'll put time on the x-axis and we'll put temperature on the y-axis. So after time, well, it's going to come, right? Even an oven, even when it's off, is going to have a resting temperature. Room temperature, 72, something like that. It's not going to be 0, though. That's for sure. Okay, unless you live in Antarctica. So it's going to start off at room temperature, and then over time, that temperature is going to increase. Okay? So that is a temperature increases slowly at first and then more quickly. So we can actually, let's make that a little bit. It's slow at first. Well, that's a little too slow. So it'll increase slowly and then fast. So that's what that looks like. So that would be A. I don't think I did a new one for B. No. And then B, the temperature decreases quickly at first and then more slowly. And this is a little tricky. Here's time again. And let's take temp. Nope, can't. Let's write temp again. This one's a little tricky because I think a lot of people will, it'll start at a temperature. Let me move that. It'll start at a temperature, right? The oven's on, so it'll be like 100 degrees. And a lot of people would want to do this. And, you know, that's not really how it would go. It would actually, temperature decreases quickly. This would be slowly. So slowly would mean we would go actually in this direction. It would have that shape, okay? And then it decreases quickly at first and then more slowly. So it's planing off and it's keeping that temperature, all right? So those are really good interpretations, interpreting a question and then being able to draw a diagram that represents that interpretation. So very, very important skills. Congrats. Hopefully you understood all those. And if you didn't, you took the time to learn it, to practice it. You can look up things online on Khan Academy and other things. So other places on the internet for you to dig or deep dive onto things. You should be inquisitive, and it's important for you to look into things and seek out knowledge. All right, good luck.